Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is lesson 2-8 for course 2, 4th period. This section covers scientific notation. Our objective is to write numbers in both scientific notation, which we're going to learn how to do here, and standard form, which is really the regular way that we write numbers. We're going to basically convert between standard and scientific back and forth. You might be wondering, what the heck are scientific numbers? Or numbers in scientific notation, excuse me. And we do have a definition for that, but generally it's a shorthand way of writing either very large or very small numbers in a more convenient kind of shorthand type of way. Any number can be written in scientific notation though. And it has a very specific set of parameters or guidelines that we have to follow. Okay, so a number in scientific notation is written as the product of two factors. One greater than or equal to 1 and less than 10, and the other a power of 10. Okay, so it actually looks like a little multiplication expression. So if we took this number here, 7,500,000,000,000, okay, and wrote this number in scientific notation, it would be 7.5 times 10 to the 12th power. Okay, so basically just a quick review here. This number is greater than 1, or equal to 1, but less than 10. The second number is a power of 10. Okay, so as you'll recall, powers of 10, the exponent on a power of 10 tells us how many zeros follow a 1 if we wanted to write it in standard form. So for example, 10 to the second power would be a 1 followed by 2 zeros. 10 squared is 100. 10 to the third power is 1,000, a 1 followed by 3 zeros, or 10 times 10 times 10, and so on. Okay, so that's going to come into play when we do this. This isn't really overcomplicated. It just takes a little bit of understanding what the first number needs to look like and what the second number needs to look like. Really not a lot of computation involved here. It's really a manipulation of the decimal point and the numbers. The way the numbers look, I should say. Okay, so let's start with number 1. The mean distance from Mars to the Sun is about 141,750,000 miles. Write this number in scientific notation. Okay, so this was a whole number. To begin with, the decimal point is right behind that last zero. We want to move the decimal point to get a factor greater than 1 but less than 10. So we take our decimal point and we move it until there is only one digit left in front of the decimal point, and one digit other than 0, I might say. Right now that's not such a big deal because we're dealing with very large numbers. You can also do this with very small numbers and it would make a difference there. But we want to go with one non-zero digit in front of the decimal point. Okay, so then we write as a product of two factors. So this is now 1.4175. Drop all the extra zeros as the first factor. Okay, the second factor is a 1 followed by the number of zeros equal to the number of digits following the first digit. So we would have a 1 followed by 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, or 1.4175 times 100 million. Okay, quite frankly, when I'm doing these myself, I don't really do this step. I should be able to if I need to though, so that's why it's in there. But we can jump straight to our final answer here from what we did up here. Okay, so my first factor is going to remain the same, 1.4175, okay? So it is greater than or equal to 1 and still less than 10. 100 million as a power of 10 is a 10 with an exponent of 1, 2, 3, 4, 5, 6, 7, 8, or 10 to the 8th power. Okay, I did that by counting these zeros. Now, I said I don't usually write it this way. I just use this. Look here. I passed up 1, 2, 3, 4, 5, 6, 7, 8 digits on the way to getting this factor the way I needed it to look. Okay, so the exponent on the 10 basically tells you how many digits you passed up as you move the decimal point. So the mean distance from Mars to the Sun is about 1.4175 times 10 to the 8th power miles. Also, those of you that have a scientific calculator will explore a little bit with these in class, because sometimes when you get very large answers, your calculator actually gives you your answer in scientific notation. So this will give you a way to figure out what that number really means as well too. Okay, I'm going to go back to this original one and just review how this worked out now that we walked through one problem together. So here to begin with, I want to take this number and write it in scientific notation. So I move my decimal point until only one non-zero number remains in front of the digit. Then I write my string of digits until I get to the zeros. So that's going to give me 7.5, drop off the rest of the zeros. Product means times, and then the second is always going to be a power of 10. So that's going to be 10 raised to the power of, I passed up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So again, I passed up 12 digits when moving the decimal point. So that becomes my exponent on my power of 10. Okay, so here's one we did from scratch. Gone back and explained how the first one actually worked as well. Okay, there was a quick check there. You can do it now by pausing, or you can come back to it after we finish the notes for the entire section. Okay, the next question asks us to do just the opposite. Write a number in standard form. So light from the sun reaches the earth in about 4.99012 times 10 to the second power seconds. Write this number in standard form. Okay, so again, I'll go through the math with you, and then I'll also show you how you can go straight, well actually method number 2, you go straight to the answer. Okay, so my first factor is going to remain the same. 10 to the second power is 100. Okay, if you multiply the two factors, and you have your calculator if you need to see what it is, that's going to be 499.012. Okay, now method number 2 is basically what I would do. We have our exponent of 2 on the 10. So what that means is, since the exponent is 2, we're going to move it 2 places to the right. Boom, boom. So you see that that is 499.012 without even having to do any computation, because multiplying by 100, or 10 to the second power, is going to make our decimal point move 2 places to the right. So light from the sun reaches the earth in about 499.012 seconds. Okay. All right, there's a second quick check here. Please study these, review them, get your quick checks answered. Bring in any questions you have in class. Of course, we'll be practicing more of these together, but this should give you an idea of what we'll be working on. I'll see you then. Bye now.